everyone, it's Olivia here from Olivia's Online Tuition, and today is day 1 of my 25 Days to a Better Maths Grade series, and today we're going to be doing the grade 6 topic of recurring decimals to fractions. So we'll walk you through a couple of questions first, then we'll do some exam questions. Let's get to it. Question 1. Using algebra, prove that 0.8 recurring is 8 over 9. So what this 0.8 recurring means, that means 0.88888888888, an infinite amount of 8s, right? So these 8s aren't going anywhere, right? That's a good thing to establish first. Exactly what number do you have, and what will that decimal, what will the numbers after decimal place look like? Okay. Then, first thing we always do is we say whatever recurring decimal we have, we make that equal to x. So we can't work with recurring decimals in any other way. So, as you see a recurring decimal in your paper, this is always the method you do, right? So you make x equal to whatever recurring decimal you have. Then, next step is you always times that then by 10. So when we get 10x is equal to, shuffle it one place along, it's now just one further along that big old infinite amount of 8s, right? So now it's just 8.8 recurring, just one further along. And then you know to stop timesing it by 10 when you've gotten two numbers that are the same decimal place, right? Then what you do is you subtract the smaller one from the bigger one. So you do 10x, take 1x to get 9x. You do 8.8 recurring, take away 0.8 recurring, which is just 8. Because these 0.8s are going to cancel themselves out, so you do that, take that, and that, take that. And then all you do is get x on its own, you divide through by 9, so then you get x is equal to 8 over 9. And because you had x equal to 0.8 recurring up here, and now you have x equals to 8/9 here, that must mean that these are the same because x is equal to both of them. And x must be is the same letter, so therefore they must be the same. There we go, that's question 1. Question 2. Using algebra, prove that 0.47 recurring is equal to 14.3 over 90. So it's going to be exactly the same steps as before, just maybe stopping in a different place when you're timesing it by 10. So I'll tell you what that means in a second. So first off, you write out what the decimal's going to look like. And in this case, the decimal dot, the recurring dot is over just the 7. So that means that just the 7 is repeated. So it's going to be 0.4, then 7, 7, 7, 7, 7, 7, infinite 7s, right? Then for second step, still the same, x is equal to 0.47 recurring. Then times it by 10. 10x is equal to, shuffle it one along, 4.77 recurring. You want to make sure decimal point, that number of decimal places is still the same, so you can directly compare them. And then, is it the same decimal places? No, it is not. This one has a 4, this one has a 7. So that means you need to carry on. Times it by 10 again. That's what I mean by knowing when to stop. If it's not the same, just keep going. Keep timesing it by 10. Then times it by 10 again, so you then get 100x equals, a bit one along again, 47.77 recurring. So the only thing left right now is 7s. You're going to keep getting 7s when we times it. And let's have a look again. Is there any that have matched this here? And yes, this one does here. So then we stop, right? Because we've got two decimal places that match each other. So then what we're going to do is subtract them. Take the smaller one from the bigger one, 100x minus 10x, 90x. Then 47.77 recurring, take away 4.77 recurring, essentially get rid of both of those. 47 minus 4 is then equal to 43. And then same last step, divide this down there and you get x is equal to 43 over 90. And that is that. Okay, so last question for some exam questions then. So question 3, right? 0.216 recurring as a fraction in its simplest form. Okie dokie then. So remember, first step that we always take is let's write out this recurring decimal to see what that decimal is going to look like, right? That little bit at the end of the decimal place, which is what this symbol is meant to mean. So we got there 0.216, and then when you got two dots, what that means is that everything between these dots is repeated indefinitely, right? This one is going to be 216, 216, 216, 216, 216, forever and ever and ever and ever and ever and ever, right? next step then, x is then equal to 0.216 recurring, and then times that by 10 again. 10x is then, shuffle it one place along, 2.162 recurring. So always make sure you have the same number of decimal points at the end of your decimal, right? Make sure it's the same number here and here. And it's going to move down one, and then let's check, is this the same? It is not, so let's keep going. Then we have 100x is equal to, move it along again, 21.621. Again, not the same as any of these, so let's do it again. 1000x is then equal to, shuffle it one more time. We've now finished a whole one, haven't we? So then we've got 216.216. And if we have a look, this is the same as this one here. So this we can now subtract. So take the smaller one from the bigger one, which is then 999x equals 216. Take away nothing because he's going to cancel out. Gives you 216. And then we're going to divide that down there, and you get x is equal to 216 divided by 999. Then we want to make this a fraction in its simplest form. You can simplify in here, right? So let's see, what numbers go into both of these? So I know I'm going to start with 2, but 2 doesn't go into this one. So no ball there. Let's have a look. And then 3. So the way we tell if a number divides by 3 is if we add all the digits of the number together and it's a multiple of 3, then that number will divide by 3. So if we add all these numbers up, 2 plus 1, that's 3, plus 6 is 9. And that's the multiple of 3, so it will divide by 3. And then we've got 9 plus 9 plus 9, that's 27. Multiple of 3, so that will indeed divide by 3. Then divide both of those by 3, we then get 333. And then on top we're going to get 72. Okie dokie, and then let's double check again. So again, 2 isn't going to this one, so no 2s. And then 3, 7 plus 2, that's 9. That's multiple of 3, we're going to divide that one by 3. Then 3 plus 3 plus 3, also 9, so I can also divide by 3. And there we are. Divide both of these by 3, we then get, let's have a think, 24 over 111. Okay, and then let's try it again. 2 plus 4, that's 6. That'll divide by 3. 1 plus 1 plus 1, that's 3. Also divide by 3. Okie dokie. And then we get over 37. Okie dokie. And then that's as simple as I can make it, because 37 is prime, I'm pretty sure. Sounds about right. So then this is the simplest number that I can get. So that is the end of question 3. So next up, exam questions. Okay, so pause the video now to have a little go yourself. And this is from the June 2019 paper 1 from AQA. But if you are doing Edexcel or OCR, don't worry, you can still do the question, just good practice all round, right? To see other example, it's good practice. So yeah, pause the video now, have a quick go yourself. Okay, question 19. Circle the fraction that is equivalent to 0.1 recurring. Okie dokie then. So we know the steps at this point. Make it equal to x. X is equal to 0.1 recurring. Then times it by 10. 10x is then equal to 1.1 recurring. We're already at 2 numbers with the same decimal places, so we're going to subtract already. We're going to get 9x equals this, take away this, which is just 1. So then we're going to divide through by 9, bring that down there. X is going to be a 9th, so it is this option right there for 1 mark. So this one's from the June 2020 paper 3 from Edexcel, so a recent one. Remember, pause it, have a go yourself, then we'll go through it. So question 15. Prove algebraically that 0.73 recurring can be written as 11 over 15. So first things first, let's figure out what that decimal is going to look like. That's going to be 0.7 with a whole load of 3's, right? 3's for days. These can kind of carry on forever and ever and ever and ever. Then what we're going to do is x equals 0.73 recurring as the method begins, right? Times it by 10. 10x is then 7.33 recurring. Just shuffle that 1 along there. Let's check, are these the same? They are not. Let's just carry on. Times it by 10 again. 100x is then equal to, moving along another one, 73.33 recurring. And hey presto, that is the same as that. So we can stop. And it subtracts them. 100x minus 10x, 90x equals 73. Take away 7, which is 66. Okay, and then let us divide that 90 down there to get then x is equal to 66 over 90. Right, and then that's essentially done, to simplify it, to get this number here. So what have they done to get from that to that? So I can tell they've divided 66 by 6 to get 11, right? So assuming they've also divided by 90 by 6 to get 15, which sounds about right. So we're going to divide top and bottom by 6 to then get 11 over 15. And that would be 2 marks on the Excel paper. Okay, this one's from the November 2018 paper 1 from Excel. So again, pause it, have a go, then we'll go through it together. Question 16. Prove algebraically that 0.256 recurring can be written as 127 over 495. Okay then, so first thing is to figure out what is that going to look like. So we've got 0.2 and then these 2 are repeated forever because that's where the dots are above them. So 5, 6, 5, 6, 5, 6, 5, 6, 5, 6 forever and ever and ever and ever and ever. And then let's get started, get stuck in. So we've got then x is equal to 0.256 with the dots above those. And then 10x is going to be, shuffle it along one, is equal to 2.565 with decimal point, with, oopsie daisy. Your recurring decimal is really on any of them, doesn't really matter. It's just for your benefit at this point, but let me get rid of the one on the first one just to make it look a little bit neater. There we go, get rid of some of them, there we are. Okie dokie, and then these are not the same, so we carry on. 100x is then equal to, move it along another one, 25.656. So again, not the same, so let us continue on. 1000x is then equal to 256, shuffling it along one, 266.565. And then this is looking an awful lot like this. So we are now done. Put on the brakes. Let us start subtracting. So we can then do 1000x, take away 10x to then get us 990x. And then we can do 256 minus 2, 254. And then last step, divide that down there. X is then 254 divided by 990. Okie dokie then. And now is a task of making this look like that, right? So let's have a little think. So what I'm seeing here is that I know that 27 times 2 is 54. So 127 times 2 is probably also going to be 254, right? That's what I noticed first. So I'm betting they've just halved this fraction. But let's do that, see what we get. So let's half the fraction and we get 100, and then 54 is 27. And then half of 990, well, half of 900 is 450. Then half of 90, that's 45. Add those together, it's 400. And then 50 plus 4 is 90. And then 5. Would you look at that? 495. And that would then be 3 marks. Okay, so this one is from the November 2017 paper 1 from Excel. So you know the drill by now. Pause it, have a go, see how you do. Okay, so question 15. X is then equal to 0.436 recurring. Prove algebraically that x can be written as 24 over 55. So they phrased it slightly differently this time, but no matter, all that means essentially they've done the first step for us, haven't they? They've already written it as x equals 0.436, done the first bit for us. But let's do what we normally do. Let's figure out what this decimal is going to become. So that's 0.4 and 36, 36, 36, 36, 36, okay. Then let's times this by 10. So 10x is then equal to, move that over there, 4.363. Like that, okie dokie. And then times it by 10 again, 100x is then equal to 43.636. Okie dokie. And then next one, 1000x is then equal to 436.363. Shuffling a long one. And that is then, these two are the same. So let's subtract them. So 1000x takes 10x, 990x. 463 take 4, that is going to be 432. Divide that down there, as we normally do. X is equal to 432 divided by 990. And then we're trying to make this into this. Looks like we've got quite the way to go to get there, huh? So what I would do is, let's divide one of these numbers by this, just to figure out what they've divided by, because if we've done it right, it should be the same thing both times. So let's just do that, make it a bit easier rather than just keeping cancelling down the fractions. They could ages, right, with this one. So what I would do here is figure out how many 24s fit into 432, or how many 55s fit into 990, but I'm going to go with the smaller option. So I'm going to divide 432 by 24, so I'm doing 432 divided by 24, and I'm going to simplify this fraction. You could put it into bust up, but bust up with big numbers, never fun, is it? So I'm going to put it as a fraction for now, simplify it, see what I get. So then I'm going to divide that by 2 to then get 200, and that's then 1516, just 30, and then add in the 1 from the 2, divided by, that is then 12, divided by 2 again, 108, divided by 6, divided by 2 again, that's 54 over 3. Then 54 divided by 3, that is 18. Okay, so then I know that they must have divided 432 by 18 to get to 24. Let's go at that then. So that will then give us 24 over 55. And then to show them what they've done, they have divided by 18. And there we have it. If you wanted to check that was definitely right, try and do it with the bottom one as well. So if we did 55 times by 18, that should give you 990, which it does. So there we are. Hey presto, done and dusted. If you did simplify the full fraction, it just kept whittling down, dividing by 2, then 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 it would still work. Do not worry. It's just this is a bit of a quicker way. But either or, both methods, perfect. So here we've got June 2018, paper 2 from AQA. So pause it, have a go, see how you do. So question 27, prove algebraically that 2.75 recurring converts to the fraction 124 over 45. So we haven't had it where there's a number here yet, but method does not change, right? So let's make a start then. So that is going to be 2.7 and then with a million fives, right? Fives all around, fives just continuing on, right? And then x is then going to be 2.75 recurring. 10x is going to be 27.55 recurring. 100x is then going to be 275.55 recurring. Okie dokie then. So let's put it in just one of them. So then this we've got the same. Subtract 100x minus 10x, 90x. 275, take away 27. Gosh, it's good to be paper 2, isn't it? Calculator time for that. 275, take away 27, and that is 248. Then divide that down there, we get x is equal to 248 over 90. Then we want to make this equal to this, and I can see that they have halved it to get from there to there. So let's divide it by 2. And that gives us 124 over 45. Pace count almost getting in the way, but not quite. And that is the answer. 3 marks on an AQA paper. Okay, so last one. It's a tricky one, this one. So this is the June 2017 paper 2 from edX. I'll give you a clue for this one. The only thing you can do with recurring decimals is what we've already done today. So if you want you to do anything else with it, maybe do that thing first and see what you can do from that point. That's your clue. So have a go, see how you get on. Question 16. Using algebra, prove that 0.136 recurring times 0.2 recurring is equal in value to 1 over 33. Okay, so we're going to essentially be doing this twice, aren't we? Because we've got two different recurring decimals. So let's do them in different colours. Let's do the first one in blue. Why not? So this recurring decimal is going to be 0.1363636 over and over again, right? Now we figure that out. Let's then x equals 0.136, just like that. 10x is then 1.363. There we are. And then 100x, and we'll just keep going. 13.636, not there yet. Then 1000x is then 136.363. And there we are. So then this one is the same as then this one. So we're going to subtract these two. We're going to do 1000x, take away 10, which is 990x. And then 136 minus 1, 135. So then divide that down there. We then get x equals to 135 divided by 990. Okay. Can we simplify that? So we're going to be multiplying these fractions together. So let's simplify it, make our lives a bit easier. So if we divided all this by 3, let's double check. 9 plus 9, 18. That divides by 3. 1 plus 3, that's 4. Plus 5 is 9. That also divides by 3. Let's divide both sides by 3, top and bottom by 3. And we get 45 out of 330. And then I bet we can do that again. So then we would get 15 out of 110. Okay, so then we're going to divide this by 5. So then we get 3 over 22. Divide that by 5. Okay, so that's the first one done. And then next one, let's do this one in purple. Why not? Make it nice complementary colours, I suppose. So then 0.2 recurring. That's a bit easier, isn't it? There's 0.2 recurring. That's just 0.2222222 forever and ever, right? So then x is 0.2 recurring. So then 10x, that is 2.2 recurring. Got matching already. So then we're going to take them away. 9x is then 2. Divide that down. X is equal to 2/9. Easy peasy. Then all we're going to do is then let me change colour back to red. Times these two together. Let me do it over here. We're then going to get 3 over 22 times by 2 over 9. And that is then going to be 6 over 198. And then we want to get that to be equal to 1 over 33. So I bet they've divided it by 6, haven't they? Get from 6 to 1, that's divided by 6. So let's just put that down. So they've divided by 6 to then get 1 over 33. And that is all the questions. So there you have it. That was day 1 of my 25 Days to a Better Maths Grade series. If you have enjoyed, feel free to like, subscribe, do all that YouTube stuff. Tomorrow we're going to be doing direct and inverse proportion, so y equals kb kind of stuff. So yeah, hope you've enjoyed, and I'll hopefully see you all tomorrow. Bye!